All right, let's get going. Hello, everyone. Thanks for being here today for this third episode of the FME Server webinar series. It's always nice to see a lot of names that have been there since the first episode to see you among us today, as we're almost halfway there. And also some new names that I see on the screen. So welcome if you're a first time, and welcome back if you're coming back for this episode. Today we're going to be joined by, for the first time in the webinar series, by Felix. Felix is my colleague. He holds a bachelor's degree in environmental geography and a master's degree in geographic sciences from the University of Sherbrooke. In 2016, after working as a research assistant for almost 2 years, he joined the Consortec team as a geometric consultant. Since then, he has been involved in projects implementing geospatial data processing and integration solutions, as well as providing training and technical support on the FME technology, with which he has obtained FME professional certification. And by the way, I almost forgot, well, I did forget to introduce myself. My name is Marc-Olivier Bourdeau. I'm the marketing coordinator at Consortec. I'll be the moderator during this session. So if you have any questions, let me know. There's a Q&A section on your left, and I'll try to have Felix answer them as the webinar goes on. But we're definitely going to have a Q&A session at the end. So that's it. Felix, you can start.
All right. Thank you, Marc-Olivier. All right. So today we'll be talking about how to use or how real-time can be represented in FME Server to do some data processing. So agenda for today, brief introduction on FME. What is near real-time in FME Server? What are the specific conditions that are required to have a successful real-time or real near-time processing on FME Server, how to set it up, and of course, later on, a couple of demonstrations. So for those of you who are new to FME, I'll go briefly over these slides, but in case you're not familiar with the software yet, it's a data integration platform which comes in 3 flavors, if you allow me to take the expression that my colleague Leslie used. So you have FME Desktop, which is the basic software in which you build your workflows to extract, transform, and load your data. And then you have the server and cloud versions of the software, which are more the enterprise level of the software that allows you to orchestrate and automate these workflows using more tools, if I can put it this way. So the idea behind is that you can automate your workflows based on different triggers, whether it's a schedule or an email notification or many other things. You can build the automations depending on these triggers, and eventually the end goal is to eliminate manual effort and complex and repetitive tasks, which take a lot of time. So in the end, the goal is to make the data flow easier and put less pressure on your work by eliminating all the manual work part of it. So what is near real-time in FME Server? So what we mean by that, it refers to FME Server's capabilities of performing tasks and running processes on a timely fashion that is real-time or very close to real-time. So there's 3 main possibilities we'll be viewing today. First one is repeated scheduling. So on FME Server, you can have schedules which will trigger workspaces or different actions. So the idea behind this first part is that we'll be using on a frequent basis many schedules to have a close to real-time data processing. We'll see how external applications can trigger workflows on FME Server, so it's almost like on demand, which is pretty much real-time in that case. And we'll also go over the WebSocket protocol and how FME can use that protocol to get real-time data feed.
All right, so I have a question for you, Felix. Could the REST API be used to trigger processes on FME Server?
Yes, that's a good question. So the REST API of FME Server allows for other applications to connect to the backend of FME Server and then call different functions for on FME Server. So in a way, the REST API can go like the work like the external application triggering a workspace on FME Server, so which would be kind of a real-time use also. But we have a next webinar episode on the REST API, so I'll leave more details to my colleague who will do that session.
Thanks.
Thanks. So what specific conditions are required for real-time to be used on FME Server? First of all, consider your source data feed. So is it being refreshed on a real-time basis? If it is, then we'll see how FME Server can grab that data feed and use it in your workflows. Or is it on a more of a delay in the refresh time? So is it 10 seconds, 1 minute, 5 minutes, once a day? What do you consider to be real-time is the question. So it depends on your needs. Maybe just every hour is sufficient and you consider this real-time because your data set is always almost up to date at every hour. But if it's more time sensitive, we can lower this. The third part to consider is how other applications that are integrated in that workflow, how do they support real-time processing? So if your other applications that would use that data after the processing, can they handle real-time or close to real-time? So we really need to go over these questions first. I mean, real-time is a very, very interesting thing, but is it really necessary, or how necessary it is? So in terms of time, is it required to be real responsive, or can it be more on a couple seconds or minutes delay? Is it sufficient? So these are the type of questions we need to figure out before beginning or trying to go very far into real-time processing. So first of all, the first technique is repeated scheduling. So the idea here is to build a schedule on FME Server that will be repeated multiple times a day. I have a quick screenshot here of a schedule being built in FME Server. So you see schedule type is repeat on interval. Every 5, now I'm going from minutes to seconds here. So the goal behind this schedule is that every 5 seconds, there would be a workspace running. Of course, I need to make sure that the workspace that is running runs in less than 5 seconds. It may be a bit extreme. I'll go more towards 10 or 30 seconds in the example in order to be able to refresh the data set and not cause any conflict. But you see how far you can go. You could go to 1 second eventually, but that's kind of being very, very bold to go this way. But you have a lot of options. And in most cases, doing a repeated schedule is sufficient for most use cases that we've seen in our projects. Second case is an external application trigger. So the idea is that there's an external app or system that sends a notification to FME Server. So upon reception of the notification, FME Server can trigger a workspace or create a new notification. The picture we see is the notification service architecture on FME Server. On the left-hand side, we have the client application sending a notification. Then on FME Server side, there is what we call the publication part that will be listening or receiving the notification. There's many different ways of receiving a notification. It could be an Amazon SNS, an email reception. It could be a HTTP post. It could be a WebSocket. It could be different things. Once the application receives that notification, it publishes it to a topic. And that topic is kind of the center part of the notification service, on which are subscribed what we call subscriptions. So once the publication got a notification, publishes it to the topic, and then the topic can then trigger an action on the subscription part. So the subscription part has different protocols as well, including what we call an FME workspace. So, I mean, it's a workspace. So the data processing will happen at the subscription part, but it could go further. So like send another email notification, many different things, an HTTP push or a post, which will in the end be used by the receiving application on the client side. So that's how it was on FME Server for up until 2019. In 2019, there's a new way of doing these automations called automations. Actually, I kind of put the punch first. So instead of going through the 3 different pages of publications, topic, and subscriptions, it's a more visual way, or kind of a FME workbench way of doing these, building these integrations. So you've got on the left-hand side like an email notification that would then trigger workspaces. We're bringing back the data flows on the merge part and trigger or send notification to the destination part on the right-hand side. So it's more visual, it's a bit easier to work with. We can use them on FME Server 2019. I won't go into too much details, as the first episode of our webinar series was dedicated to automations. Third way is a WebSocket stream. So it's on using a WebSocket service that will provide data stream using a WebSocket connection. So if you don't know what WebSockets are, I'm doing here a comparison with the HTTP protocol. So on the left-hand side, we have a client machine that wants to make a request to a server. It opens up an HTTP connection. The server then sends a response, and the connection is closed. So each time there's a request, the connection needs to be open, and then after the response is sent or received, the connection is closed. So it's really transactional. Connections need to be open and closed each time. It's what you have whenever you're browsing. Most of the website is HTTP protocol. It's very fast. You don't see it, it's in the back end. However, it's transactional. So connections need to be open and closed each time. It's still fast, but it's a lot of transactions going on. Whereas with the WebSocket protocol, the connection is created. The client can make requests and the server send responses, but the connection is always open within the request and in between the client and the server. It's the same connection. So that means that it's not as transactional. It's like the same stream being used. We see it as the protocol behind a lot of chat applications online. So you can see the messages coming back real fast, or in gaming applications, we'll see a lot of WebSocket being used behind. So it's the same stream. It's not open and closed, and then it needs to be closed kind of manually. So on FME Server, what happens is that FME Server reads the stream, so it connects to it, and then it uses information in the stream to write to a different output, like a database, files, etc., or use that information to process within a workspace. The WebSocket stream triggers the notification service, and FME Server can also send out another WebSocket stream. So we've got the send-in applications building or creating the WebSocket stream, which triggers the WebSocket publisher that is listening to the stream, which then triggers a topic, which will trigger the workspace subscriber and then run the FME workspace And on a second level, the FME workspace can also publish to a topic, which goes to a WebSocket subscriber, which can stream a WebSocket stream to a receiving application. In FME 2019, if I kind of hide the boxes behind and use the new words, WebSocket stream will go to a trigger, which will trigger an action such as running an FME workspace. And then once the workspace is ran, there could be further action going on, or an external action like sending a notification or a WebSocket stream.
All right, so just to clarify, Felix, can FME Server read and produce a WebSocket stream?
Yes, it can do both. So it can connect itself to a WebSocket stream, and it can also send a WebSocket stream. So it can do both. That's a good question. Yeah. All right. So here's a few tips on setting up near real time in FME Server, and also a little part on FME Desktop. So what you want to consider when you want to implement real time on FME Desktop when building your workspace. First of all, there's a few transformers that I've listed here that can be used to handle the data to receive. I've included in that the text file reader, so it's not a transformer, but it's the reader. We'll be using it a lot to bring the text notification into the workspace and work with it. So most of the time it will be like a JSON string or an XML string that needs to be broken up or broken down into pieces that are then being used to trigger the workspace on a specific condition or for a specific data set, for example. The HTTP caller is a really good tool to go grab data online or to post. So connecting to APIs as well. And I've put two example receivers, such as the GMS receiver or the WebSocket receiver. So they are built to receive a specific type of information in them that can be used in real-time processing. And once you've received the data to handle, use other specific transformer to perform further tasks. So in that case, could be an FME Server job submitter. So you could have like a master workspace that first grabs the notification, breaks down the JSON string, and then use the information in the JSON to trigger the proper workspace or the proper workspace with the proper parameters. It could be also the FME Server notifier or WebSocket sender. These are just a few examples of transformers to use in building workflows that handle data in real time. On the FME Server side, first thing to do is to watch for the data stream. If you're using FME Server 2019, go through the automations using the triggers and action to watch for the stream. Here the stream kind of refers to WebSockets, but it could be something else. If you're not on 2019, you'll be using the publication, topic, and subscription method. The response text will have to go through FME Server first, so make sure to know if it's a JSON, XML, or another thing. Then will be sent to the workspace for processing. So in the third part, you run the workspace or trigger another action. Demo time. So I'll go through the different response. The different methods. Oops, sorry, need to exit. First of all was the repeated scheduling. So I'll go to my workspace first. I have a quick workspace that reads data from the Montreal Bixi website. If you don't know what Bixi's are, there are a bike sharing service in Montreal region, and they have a map in which we can see how many bikes are left at each station and how many docks are left. Of course, we're a bit off season right now, but they do have an open data feed that is available online as an XML page, and each time you refresh the page, you get the latest information on each stations. So it is real time. Each time you refresh the data, you get the latest information. So in that page, you can see each station is divided with the station ID, the name, the coordinates. We have number of bytes and number of empty docks that are being there. And what I'm doing is that I'm grabbing that XML through the HTTP caller. I'm breaking the XML into each stations, building points, reprojecting, adding a timestamp, and in the end, I'm writing this to a PostGIS database, which I want to update based on a schedule, just to keep track of all that information. So that workspace is published to FME Server. I'm into so I'm on FME Server, already connected. I'll go to the schedules part. I already had set it up. I'll show you how I did it. So once I've put in the name and the category, I build the schedule to repeat on interval every 30 seconds. I was doing 10 seconds before, but it was a bit too fast to refresh with my PostGIS database. So we'll better see with every 30 seconds how it goes. I just then choose the repository in which the workspace was saved, parameters, click OK. Oops, I forgot to check enabled. Now it will be running. So it is running. If I go to my jobs part to see the logs, I'll see in a few seconds when it was finished. But you can see today it was before at every 10 seconds, and then I'll refresh in a couple of seconds to see that a workspace ran correctly, and I'll do a refresh on my database side. So this was this is my PostGIS table, and I have an update date and time field that we can see here. I'll see if my job ran successfully. 3:24, so that's the latest time. If I go refresh my tables now, I can see my update time has been synced. So I could lower the time in the repeat interval to have it faster. I just put 30 seconds now because I wanted to be able to refresh the database in pgadmin and that you could see the result. But it was working every 10 seconds. It was just a bit harder to get the synchronization on the pgadmin side, but it was refreshing correctly. So that's pretty close to real time in a lot of cases and sufficient in at least most of the projects we've seen. The second method I wanted to show is an external application triggering a topic on FME Server. So again, on PostGIS, I have a building table here, which has, I'll show it on QGIS to see spatially, some buildings in the Vancouver area. So it's a data set from Safe Software. What I want to do is to, whenever I have a new feature, so whether I perform an insert, an update, or a delete on a feature in my database, I want to trigger a notification on an FME Server. So it will trigger a topic, and then once the topic is triggered, then I could do anything I would have subscribed to that topic could then run. So I just wanted to show you how this works and that it is very responsive. So in between the database and FME Server is a little application called Node.js. So it's a JavaScript application that can do the bridge, or kind of the bridge in between. I have a trigger on my database here that will send a notification as a JSON string whenever there's an update, an insert, or a delete on my building table. First of all, though, I need to run my Node.js application in order to be able to push the notifications. So I'm in here, it's in my program files. I just need to call it node and then call the JavaScript file to be used. So let's post the GIS to topic. And it's now running in the background. Now, if I go to QGIS to edit, and I want to add a new feature, I'll go on toggle editing, create new feature. Oh, first of all, I'll go to my notifications, go to topic monitoring. So I have my post GIS test topic, which will be triggered if I have an insert, an update, or delete. So I'm creating a feature here. I'll just leave everything blank for now. And when I'll be saving, you see, boom, the topic has been triggered here. So I have my JSON string, PostGIS test topic ID. So this is the new ID of the feature in the building table with the type insert. I could use then that JSON string in a workspace to do any update or processing that would be wanted in that case. So you saw it was very fast. It needs the JavaScript application running in the background. This is the type of notification that it gets, but it's really responsive. I mean, once it's running as long as I'm not closing it. If I do it once more, I'll just delete the weird building I just draw. Delete, and once I'll be saving, I can see now my new notification is set to delete. So this is just to show you on a very high level how an external application can work with FME Server kind of in the background, but then this is pretty real time. So if you be wanting to do like very fast or real-time updates or processing based on this type of operations, you could have, it doesn't have to be Node.js. There's other ways of doing it, but I just wanted to show you one that is easy to set up and very fast. So you saw, as soon as I saved the modification, the topic was triggering on an FME server. Last thing I wanted to show is the WebSocket example. So I show you how kind of nice it can get on FME Server. So this is an example based built by Safe Software, showing different transportation methods, or like there's planes, there's boats and buses in the San Francisco area, and there's a WebSocket being diffused or streamed by FME Server to show how these entities are moving. So if we zoom in, we see different the planes and the boats moving a little bit. This is a sample data set, so it's not actually live in the region, but there's a WebSocket sending all that information behind there. On a more basic example, I'll show with the FME Server Playground how it sends a message on a WebSocket connection. So it's a very simple web page. I'll open a WebSocket. I've also opened the Google Chrome console to see the WebSocket stream being open on the right-hand side. And of course, I have an FME workspace open here with the WebSocket receiver, and we'll be seeing the message being pushed into the logger in the translation log below. So in my web page that I have here, I'll just send a simple message like hello friend here. Start the WebSocket. I'll start my workspace, and you'll notice that the workspace is continuously running because as I was mentioning, WebSocket connections are always open unless we close them. It's not transactional. So now I see WebSocket receiver, handshake successful, so the connection is open, waiting for incoming WebSocket messages. I see on my console side the WebSocket streams being open. I can click send message, message is being sent, message received. I've got my JSON string with hello friend here, and I can see now it appear in my logger. The way the page is set up is that it closes the connection after, so I need to start it again. Just to show again, send message. I have my JSON string here, and I had a second time here the same information going into the logger. So pretty instantaneous again. We've got the message in the receiver. We could use JSON fragmenter or any other string transformer to work with that JSON string to update our data or trigger other processes. So it's not too much more complicated than that. We can see it was very responsive, and it would just need to be published to FME Server to work around that. So that's pretty much it for the WebSocket part. Go back to the PowerPoint now. We have other webinars coming up. So in 2020, a few ones on what we call the self-serve modules. So, but before that, we have an application integration with FME Server, and then three little chapters on what we call the self-serve modules. So we'll see the directory watcher, the REST API, as I was mentioning before, and the apps on FME Server. So these are very interesting topics. So thank you, everyone.
All right, thank you, Felix. Thank you, everyone, for being here. We're going to take questions now. Meanwhile, yeah, as Felix said, we're going to take a little Christmas vacation. We're going to be back on January 15th. In the meantime, if you have any comments on the webinar series, if you feel free to send them to me at marketing@consortech.com. If you have any comments, or if you have any questions, or if you would propose any content, if you want more demo or whatever, anything, we'll be pleased. I'll try and accommodate you guys, because basically we're doing it for you. So let me know how you like the webinars. I have a question for you, Felix. Before we take other questions, I wanted to know, you showed us a few techniques for real-time processing, but what are the main things people need to consider to choose which technique is the best for them?
That's a very good question, Marc-Olivier. How to choose the best method? First of all, I would say is it will depend on your data source or the application from which the data you want to grab from. So how is it fast to connect? First of all, is it refreshing on a real-time or close to real-time basis? If it is, then great. We'll see which is the best way in FME with any three methods to go get that information. But if it's not, then maybe we can see if, not behind the scene, but if you have some flexibility on how you can work with that data, if it can be modified or adapted to how it's sent to FME Server. If that is an option, then we could also, it would be also worth investigating. So what I mean by that is a bit with the Node.js example that I was mentioning. If you can install a third party that could do a bridge between the database and FME Server, or another application that could allow access to FME server, then we could use any of these techniques also for the real-time or near real-time processing. So don't forget, it depends on your data source and how frequent you want the data to be refreshed.
We have a question here. Says our FME server installation is installed behind our company firewall. Is this possible to use WebSockets even though our FME server is locked behind a firewall? Internal installation. For instance, to access FME server, users have to be connected via VPN if working remotely outside of the organization. For instance, I'm not able to receive webhooks because the external service can't reach our FME server instance. So
that's a good question. We have to see different permissions with the IT side and different ports. So if working through VPN is not working once you're into the network, we have to see if it will depend if the WebSocket stream you're trying to access is internal or external. If it's external, then I've seen in most cases, since it's like a stream, they're a bit more protected. You need user credentials and a key to connect to a bunch of WebSockets that I've been seeing. So aside that, you'd have to make sure that you can at least get to the web page where the stream is, and then maybe you'll need to open a few firewall ports for that communication to get in. But if the stream is internal, then I don't see any problem to it. It depends on where it comes from. If you want us to investigate this a little further with you, we'll be happy if you send us an email and we can dig in that subject a bit deeper.
All right, thank you. Thank you for the question. Thank you everyone for being here, and happy holidays. We'll see you on January 15th. Have a great day.
Thanks.